Okay. Right. So good morning, everyone. I hope you had a good break and getting ready for the next week's prac exam. Okay. So just another reminder, I said that before. This is in case you didn't attend the Friday lecture. Please make sure that you know how to submit via the SVN. This time this is worth marks. This prac exam is worth marks. So I hope you spend some time getting ready for the prac exam next week. This week is your chance to, 1, make sure that you know how to submit via SVN. 2, if there are any issues or any places that you don't really understand in the workshops or practicals, please do approach a tutor and make sure you clarify those spots. Okay, that's very, very important. I'm repeating this in case some of you were not here on Friday. Okay, so on Friday we talked about the pointers and how to access pointers, how to manipulate and so on. We will continue. I want to do a little bit more on exercises, and somebody told me, I think Jason, Joseph, somebody told me that you didn't really cover the heap. You didn't really cover the heap, so I will briefly talk about that too. Okay, so this is an example. So now you should know about stack. What do you know about stack? What can you tell me about stack? Yes? Sorry? That's first in, last out, or last in, first out? It's the same, yeah. So last in, first out, right? That is, you will understand, you will later understand there's a data structure called stack. You will define a stack and you will define operations later on. But that is the behavior. What does that mean? That you put something and that will be the last thing that you put will come out. So how does it relate to a function call? So okay, that's last in, first out. Can you tell me what happens? Okay, so you have the main program. Main program calls function A. Okay, within function A you call function B. So what happens with respect to stack?
Function B will be loading to stack last.
Yeah, so main will be there on the stack. So just think about it as like stacking on plates. So you have all the details about main. What do I mean by all the details? The parameters and all the related details in main, local variables that you have defined. And then function A, the activation record goes on top. Then function B goes next. So main, function A, function B. Okay? You can visualize. What is the advantage? Then when you return from function B, that is the last point of reference, right? You finish function B, you return from function B, right? Then everything that you have finished or everything that is related to function B comes out of the stack. It forgets. Okay? Then it is now within function A. It finishes that. It forgets function A, that means it's thrown out of the stack, and then it goes to main. When the program is finished, the main, the details about the main is also thrown out. So that's the idea. Now, if you know about recursion, how many of you have worked with recursion, heard about recursion? Okay, what is different compared recursion to a normal function call? What is the difference? Okay, so for those of you who don't know recursion, we will be doing that. Simply it means that it calls itself repeatedly and there is a terminating point, and then it keeps, so think about the stack. The first call goes there, then it calls itself. The second call, third call, fourth call, fifth call, and so on, until there is a point that it cannot go further. It returns, and it's thrown out of the stack. Okay, so that's the idea. So an implication of recursion is, if you don't write it right, if you don't write it correctly and it keeps on going, what happens to the stack space?
It will go. Yeah.
it's going to finish, it's going to overflow. Okay, so you have to be very careful with when you're writing recursion. What is another way to intentionally cause a stack overflow? That's one is recursion written incorrectly so that it never reaches the terminating condition. These words might not mean much to you if you don't know recursion, but just remember that, that's fine. What else? How do you intentionally write a program to cause stack overflow? Yes?
The time to loop over the recursion is too long for the computer to process, so
So you have something that doesn't
like
exist, or
the computer can only run 5 million times, but write the function to run more than 5 million times.
okay, so you're talking about a loop going repeatedly. So if you have a loop going infinitely, what happens? You have variables keep on getting allocated and it keeps on going and the stack overflow can happen. With respect to function calls, what can you do? A calls B calls A repeatedly. What happens? It keeps on stacking and it will stack overflow, right? You have to have something that never stops until it reaches the maximum. Okay, so that's the stack, right? So integer, all these variables go on the stack. Function calls go on the stack. Local variables go on the stack. Now, heap. Where is heap? So if you think about just programs in general, now when you want an array, the first couple of weeks or 3 weeks, what you did was you define the array, you define the size, it's predetermined. But what if you want to expand the array in the middle of the program? Okay, how do you write something like that? How do you allocate variables just in time or as and when you need it, right? That is where pointers come in handy. You don't have to pre-plan, you can allocate memory dynamically, right? That's what the word is, dynamically. As the time goes on, whenever you want, you can allocate. That goes on the heap. Okay, now so the advantage is you don't have to pre-plan anything, you can allocate as and when you need it. But there's always a but with most things. You have to remember, depending on the language, you have to free memory. What happens is, that is the thing that you have to remember. In some languages, if you allocate memory and you use it, but you no longer need it, if you don't free the memory, it will stay in the heap. And not for the small programs that you are currently writing, there can be situations where that is called a memory leak. You are not using it, so that's not a very good programming habit. You are not using it, you haven't freed it. Just because you haven't freed it, it can say that I can no longer, I'm running out of space, or I have run out of space, right? Now I said depending on the depending on the programming language. Why did I say that? Because some languages, that is called garbage collection, some languages do it automatically, you don't have to worry. Some languages, the garbage collection is given to the programmer. The responsibility of the freeing the memory is given to the programmer. Now, what do you think C++ does do? We have to do it, right? It has, it is an added responsibility, but some people like it so that you have the access to the low-level languages. So it is quite important, might not be very important when you are, again, for the small programs you are writing, but as a programmer, as a person who is trying to develop, grow into a professional computer scientist or an engineer, you need to get into the habit of deallocating memory. What about Java in terms of garbage collection? So the garbage collection in Java is done automatically. So that is yet another difference between C++ and Java. Okay? So heap allows you to have things dynamically allocated, and then you have to deallocate it when you finish it. So in Java and some other languages, it's done automatically. So the other thing you have to remember is the idea of a memory leak. Okay? Now, we'll go back to the questions that we have been doing. I think it's quite important because after these couple of weeks we won't be touching pointers again unless I decide to do some more examples or exercises. So let's go back to what we have been doing. I hope you all have the previous week's sheet. I didn't bring it. Anyone who, I just have one other copy, anyone who wants it, who doesn't have somebody next to you to share, so you're the lucky winner of the last copy. Okay, so question 3 and 4. We did 1 and 2, I explained. I was happy to see, I don't have any copies, but if you come with me, if you follow me, I'll give you a copy, I'll print a copy. Not now, after the lecture. Okay, you can share, you have to. Okay, anyone who wants a copy can come with me after the lecture and I'll print one for you, but I'll upload as well. Okay, so if you didn't attend the lecture last time, please do share with someone else. Okay, so the first 2 we did, right? I'm not going to go into detail, but when I walk around, if you can't remember, please ask. Question 3 and 4. Have you tried 3 already? I'll give you a minute or so just to get familiar. Okay, all good. Now, I just want to point to something else. If you look at this line, this is in question 2. Okay, so there's a pointer variable and there's an integer variable. Okay, in terms of stack and the heap, can you tell me where these things are? Where is I? Yes, I is in the stack, right? Okay, so the pointer variable here, when it is getting assigned, that will be in the heap. Okay, so remember that you have one variable in the stack and pointing to another variable in the heap. So one of the disadvantages of pointers, we talked about that, you are actually using 2 memory variables, one to point to that variable and the variable itself, right? So the pointers are good, but they also have disadvantages. Okay, let's look at this one, third one. You have 3 integer variables defined and you have a pointer. Okay, now the difference between this example and these 2, I have kind of written them in advanced order of complexity. Here you have one integer variable and that is being accessed by the through a pointer, right? That's what this is. Here simple accessing, here you are incrementing the value in the variable. Okay, the third one is about you have one pointer variable and you are trying to access these integer variables through these. That's the point of the example, right? What happens if you do this? So this is easy. You have a pointer variable and I'm saying put the address of I, just a recap, put the address of I into pointer. So I said if this I variable is in, let's say 2500, this gets 2500, okay, after this line is executed. Okay, that's called ampersand sign if you want to know. And then what are we doing here? You go value of I, dereferencing, that's called the dereferencing of the pointer, the asterisk, and you say go and get the value pointed by the PTR, so you get 42. Okay. Now these are integer variables. When you do that, I don't know how many of you try. When you go, this is called pointer arithmetic. Now you just have one pointer variable and you are manipulating the pointer value, the address in the pointer to get to the other variables, right. So I can't go into a lot of details about how the memory is structured and the scheduling algorithms and how this is done, but you have to remember, if you have integer variables like this, then what you do is, if you want to get this, you have to go -1. Now remember this, that's the important thing to remember. I said this before, this -1, even though it is known as 1, doesn't mean that it is the typical 1. It is 1 unit. Okay, why do I say that? 1 unit, 1 integer unit, because of this. Okay, if I had a char here, the low level details, the operating system and all these things, no, it is a 1 char unit. Okay, so value of I, value of L is going to be PTR -2, that is going to be 43. Okay. Now my question is, if I went pointer, the second one PTR +1, PTR +2 in the third one, what will happen? If the same program is given for the exam, right, and I instead of having this, I go PTR +1, PTR +2, what is the outcome? How are you going to answer? Determine the output or the outcome of this code segment.
I think it's a memory that is not for our program.
Okay. So if I give the same program, okay, and do that +1, everybody understand what I'm saying, right? +1, +2, then it will be a random value. Okay, because you don't know what is stored in those locations. Okay, so a possible exam question, I can give the wrong code and say the intention of the program, the following code segment is to print 42, 477 and 43, but I don't seem to get the desired output. Can you correct it? Okay, that's one possibility. Or I might go, I can't seem to get the correct output. Can you explain why? Okay. Or I will give both and say which one is the correct one for the desired output. So 3 sets of questions. I'm just kind of hinting, these are the possible things that can come. Okay, the next one. Okay. So the next one we are talking about, what is the difference? Here you have the same values pretty much, I think. 43, that is 34, that doesn't matter, but 3 values. Thank you. 3 values, but it is defined as an array. And when you have an array, so remember, you have a pointer variable called PTR, you are assigning the 0th element or the first element of the array, right? Here. So you have an array, you are pointing to the first element of the array, beginning of the array, and the way you access the consecutive elements is by pluses, +1, +2, because it's a consecutive memory location and it makes more sense to go that way. right? So that is how the whole low level support or the operating system or the compiler and all that memory allocation algorithms work. Okay. What happens if I write another one, PTR3? What will happen? It will give you a random number. Okay. So at the moment, what is the value? Outcome value of A0 43, value of A1 477, value of A2 34. Now the same way, if you try this with the minuses, you will get some random value because it doesn't make sense within this context. It will give you some value. Why is it giving you some value? Because the computer doesn't know the difference. It will just give you some value. Okay. So remember, sometimes when we give questions, it might mean that there can be some random values. Now go on to question 5, try question 5 and I'll walk around if you have any questions. Yes.
So I was just going to ask, why doesn't it just throw an error if you're trying to address value at?
Okay, good question. Now, what sort of, okay, if in the ideal world, okay, what sort of error are you expecting?
There is no value at this memory address.
Okay, so it can't give you a compilation error, right? That's understood. It compiles fine. How does it know? Think about like a computer who doesn't know anything. How does it know this is the correct value, this is what the programmer wants, and this is something that doesn't make sense to the programmer?
So it can't judge.
It can't judge.
So just, why does it give you something random?
It's okay. It's not giving you random. It's what is in that memory location.
So
That's what
it's
it means.
random in the context of the program that we're writing in.
Yes. Okay.
Okay.
Okay. Good question. Yeah.
Define an array. Does it mean that the component of that array in the memory, all of this content always has the same size?
Not the same size. It's next to each other.
Next to each other?
Yeah, but it can be a 100, a 200, a 2 million, but it is guaranteed that they are next to each other.
So if I want to give a definition for an array, the most important thing is that all of these components are next to each other.
Next to each other, and the other thing is that array has a type.
Has a type.
Yeah, so when you say integer, it cannot be mixed. Like you can't have integers and in somewhere it next to each other. So the next to each other part is taken care of by the low level details. You don't have to worry, but you can assume that they're next to each other. But the array is of some type. Okay? So there was a question, a good question. Why does it, we were talking about pointer plus 3 and so on. Why does it why doesn't it tell you that it's wrong, some sort of an error message, instead of why does it give you a random value rather than just saying this is wrong or there's something wrong?
It does not know that it is wrong.
It doesn't know. When I say a random value, you have to, that's a computer term where you say this doesn't make sense for this program. That's the value that is stored in that memory location. That's what it does. Random means random with respect to the program that we are talking about. Okay, but that's a good question. Okay, because when you say a random value, it has different, it's random with respect to the program. It doesn't make sense to our program, to us. For the computer, it goes, okay, you want this, you want the value of this memory location, I'll give you that. That's it. Okay, because you don't know at the exam and I want to know whether you know for sure, you have to say it's a random value. That's the normal terminology we use. Okay, that's the difference. But that's good that you asked. Okay. So this manipulation, how you add one, plus 1 or minus 1 is called pointer arithmetic. So you manipulate the pointer variables, the addresses in the pointer variables, just like you are adding values. But remember, plus 1, plus 2, all these things mean a unit, whatever the unit is, integer unit, character unit, and so on. Okay, question 5. Okay. So, here this is easy, right. So, I have I k both integer variables and pointer is now pointing to I because of this line. Okay. And then it says there is a PTR2 which is next to I. Okay. Right. So, what will happen here, and especially in this one? Yes?
I think for L, there's nothing wrong with L. There's something wrong with the PTR2 because we don't know which address it is pointing to. Actually, it is next to I, but it's not K.
It's not K, right?
Basically, for me, I think that L should be 1 or something because it is PTR2 minus PTR.
Okay, so this is okay, right? Value of I is what? Okay, that's a good point. What is the outcome of the first one?
It should be I.
So, what is I? That's what I'm asking.
We don't have I yet.
We don't have an initial value, so I'm going to leave it to you to find out whether it's 0 or a random value. Okay? If you don't initialize, do you get 0 or do you get a random value? Okay? So, something for you to find out. Okay? Now, PTR1, okay? Okay, before, okay, let's do this one, PTR plus 1. Now, you have PTR, so that has some value. When you say PTR plus 1, remember both PTR and PTR2 are of integer type. Right? What does that mean then? You are in PTR1, PTR, and then PTR2 means you are incrementing to the next location, 1 unit of integer, then you are looking at that one. Okay? Now, the important thing I want to highlight here is this one. Right? When you subtract PTR2, so the one that is next to, this is the second one, minus this one, what do you get? What will you be getting? You will be getting 1 because it tells you the number of units that you have, because they are next to each other and they are next to each other and they are of the same type. Okay, you can try that. Okay. So, that is something that you can try. And then here, what will happen? Unsigned long. Sorry? It will give you a hex number and it will give you a long number because it's long, it's been converted. Okay, it's been typecasted, so you will get a long number, long as in more, if you actually run that, you will find a longer number. Okay, so that's the idea here. Okay, so remember, you can actually allocate, so the point arithmetic can help you to access elements in an array, okay, access integers, and you can also reserve a place next to the one you have already defined, like this one. You have PTR, this one. Okay, so this is one use, this is another one, okay, and this is yet another one, all referring to point arithmetic. Sometimes you are just accessing the value through point arithmetic, like in the first one and this one. Here you are actually reserving a location or manipulating the pointer variable itself, and then you can put a value to PTR2. Okay, so that's the idea. Okay, let's move on to question 6. That's very, very easy. We have already done that. Okay, so if I have only this copy, I can give it to you when I leave. Okay, sorry, I have been. Okay, the question number 6 is easy. Why? Because it's an integer array and you have allocated the pointer to this one, the beginning of the array, and then you are going from pointer, the first pointer, that means value of A0 is 43, that's the outcome. Value of A1 is 477, value of A2 is 34. Actually I have repeated, sorry. Okay, now question. Can you, so I always did examples, so these are the things that you have to think of for yourself. I always go with A0. Can you start from the end of the array? Instead of A0, you should be able to, right? Then you have to be careful with the manipulation. Because sometimes you have a natural mapping, you know, the way you think and all that. So it's easier in your head to manipulate it from the beginning, but of course there are situations like sorting algorithms, searching algorithms, you might touch on this towards the end, that you will be doing it from the other ends, like you come from the 2 pointers that way. Okay, right. So start with question 7. That's a bit more detailed than we used to, you know, but I'll give you a bit more time while I keep, you know, walking around to ask. You can have the chance, but I think you need a bit more time. Yes.
The one I got last week only had.
Yeah, you didn't get a new one today. You have one copy. Can you share for the time being? Yeah, okay, can you kind of keep it, or you can look at it from the, because the full thing is given here. Yes.
When I try to run this slide, this is supposed to be like a declaration for the pointer.
Whatever.
It say this is not declared. When I try to run this slide,
It works in mine. Okay. The P doesn't work.
Yeah, the B does which was called was not declared. When I try D, which stand for decimal or in, it doesn't work.
If it is decimal, it doesn't work.
Yeah.
It's for integers.
And then
I think for decimal, for T or something. I can show you that it works in my laptop. I don't have the connector to show, but I can show you it works. Yeah, okay. Okay, maybe if you have typed, you want to show it to a tutor to ask what's wrong. Okay? You don't have laptop now, do you? No. Any questions, please do ask. Any questions? All good? Okay, so what are we doing? You have an array, 10 integers, 1, 2, up to 10, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is A. Okay, and I have two integer variables called IP, IP2. Okay, and there's another I. Okay, this says at A3, right? So I go 0, 1, 2, 3. Okay, at A3, what am I getting? The value or the address? The address, right? So the address should go into IP. That means now this is pointing to this value. Okay, so I said if you are still having issues, write a value here like 2500 or whatever and put it here, but that is what that means. Okay, IP2 equals IP plus 1, right? So this is the next to IP. It's working, right? What does that mean? So this is one integer unit. It says have the address. So you have, let's say, 2500 here, right? Add one integer unit and put it here. What does it refer to?
IP2 is pointing to
Number 5. Will that happen if it is, this is very clear because this is in an array, right? So if you, instead of having IP plus 2, it will be pointing to 6 and so on. Okay, so remember that. So that is what this is indirectly saying. You have an array, you can manipulate it that way. Okay, so some outputs. It says do this 3 at A3, right? What does that give you? Okay, so what should I write? Okay, one is you clearly have a diagram with the memory addresses so that I can read it, the memory addresses, not just scribbles, and you can write that memory address. That is fine, but it has to be clear. If not, what should you write? If I write this, is that enough? No, because you have all sorts of memory addresses, right? At least you should say this. Okay, or memory address of third in the array is the best one. Okay, just because you write a memory address, it won't work. Okay, yes. Yes, 3 is fine. 3 is 4. It should be 4. I prefer, I will still give you marks because we always consider that you are under exam stress. 4 in the array, because there can be other 4s, right? 4 in the array is okay. Okay, what is the next one? And A4. So the same thing, memory address of A4 in the array. Okay? Okay, what about these two? IP. What does IP has?
Address of A3.
Address of A3. right? You can, if you say same memory address as this, memory address as this one, that's also okay, right? Or memory address of A3 is also okay, A3 in the array, okay? Somehow I should be able to understand what you're trying to tell me. IP2, memory address of A4, because of this manipulation. It doesn't come automatically because of that manipulation, okay? Now, what am I doing here? IP plus 1, right? So, IP increment the location and then go to that and put 5 there. So, IP is here, sorry, IP is here, right? Go 1 and 2, 3, 4. So, IP didn't change, but we are saying go to A4, 0, 1, 2, 3, 4 and change that value. This still says 5, so it doesn't change, but you could change it this way. Okay? The array address, and what am I doing here? Now, look at the print statement here, A, okay, so AI, so A goes from 0 to, this says 0, comma, AI, 1 and so on. It goes like that. E0 equals 1, A0 equals 2, sorry, is A1, A2 equals 3 and so on. It goes up to A10 equals 10. Okay. Now, you don't have to write all the lines. I do expect a few, and especially the last line for an exam, for an exam answer. Okay. Now, what am I doing here? So, that's that one, and then you have a print line, and this one modify IP2, that is this line, okay, and I have 3, 4, 5. Okay. Now, a simple way to modify that line is you can do that. Okay, you can do it either way. Okay. Now, what am I doing? I am still printing, it is the same as that one, but what is the difference for the second one? You go A01 like that. Okay, 3, 4, 5. You manipulated it through the pointer, but the value will be changed. That's the point. You know, that's why we have a before and a after thing. Okay, all good? Okay, return 0. Okay, question 8. Okay, we have a few more minutes. So, if we go through the first one, there are 3 sets. Let's look at the first one. It says, so there's an array defined same way 1, 2, 3, 4, 5, 6, 7 up to 10, and it says address of A0, within you will get that, right, and you are printing A, right. What are you getting? You are printing A, you are not printing A0. Address of A0, 0th element when you say A. Okay, so you have to write address of the beginning of the array or the starting, pointer, starting address. What do you get here? Same as before, because it's the 0th element, right? That's how you define an array. If you say A or at ampersand A0, same thing. A plus 0, same thing, because A, there's no offset. Okay, this one, address of the 6th element minus 6 integer units. Same thing, you are coming back to the array, pointer arithmetic. Okay, so all these things do the same thing. So you can pick, when you're writing programs, you can pick what you want, what you're familiar with. However, you should be able to read other people, other ways. Okay, so all these things refer to the same thing. Okay, so I'll leave these 2 to you, right, and then I want to discuss a new topic, but I will touch on this in the next lecture. Again, remember, next week is prac exam. Please get ready, and if you have any questions, please do approach a tutor this time, especially about submitting to the web submission system. This is the 3rd announcement. Okay, thank you. Yes.
Question 8.